get the second phone. Let me see. Yeah, good evening, Patrick. Good evening, K-Media. Good evening. You're welcome. So as you join, like we will always do, okay, you record your name, register your presence in the class. Register your presence so we know you are here. Your name and your reg number. We saw about a minimum of about 40 votes that the class should hold. I don't want a situation where those people are not in this class. You people will be discouraging me. Yeah, Charles, good evening. Please. Subscribe to the channel as you join if you have not subscribed before. Okay. Subscribe to the channel if this is your first time. Give a thumbs up to the video. It's important. Okay, so this is 7:48. Okay, so we have about a few minutes to start. Is connected. I've connected it now. Okay. Today's class. Oh, damn it. Okay. Okay, so I'm beginning this class immediately. Charles, you're welcome. Okay, we are beginning this class. Please, you can go to the WhatsApp group and inform every other person to join the class. Okay, so yesterday we got into looking at the concept of distinct quadratic denominators, and we saw some examples. However, we got somewhere where we needed to clarify, and I am going to give clarification. But before we left, Munachi was saying that there was a place we forgot something, and yes, when I looked over the video, praise you're welcome, when I looked over the video, I saw where we made a little mistake, so which we are going to look into now. Okay, so let's try to solve this again. So this is repeated linear, and I'm mentioning this because when we come to exam, meanwhile, good evening everybody, how are you doing? May the Lord grant us grace and understanding for this class. I've not been doing this and I think it's not correct. So we are supposed to commit our learning into God's hands so that He will guide us and grant us understanding. And so may His Spirit help us learn effectively today. In Jesus' name, amen. Okay, so let's go on. So here we have, now I was saying something about the reason why this example is important is that, for instance, you could have something like this. And this is another example which we are going to look at, or maybe I can give you that as an exercise to try on your own. If you are given something like this and you're asked to simplify it into its partial fractions, okay, so these are some of the tricky questions that we bring to exams, okay, and so you have to know first of all what type of fraction this is to be able to simplify it into its partial fractions. Okay, so again, this is also going to be repeated linear denominators because of the x squared here. Okay, so I am going to keep that somewhere, and then maybe when we finish this example we could look into it. All right. Okay, so here, like we said yesterday, we are going to have a all over, so we pick the first linear denominator of x squared, which is x, then plus b all over, the second one will be x squared, then plus c all over, the third one here is x plus 2. Okay, so I'm sure we got to this point. So the next thing is to get LCM, which we did, so which is x squared into x plus 2. All right. All right, so here if we divide, so we got a into, okay, there will be x squared, x that will be left here, so this will be x into x plus 2, and then plus our b, so b into x squared, we divide x squared, so we just have x plus 2, and then plus the final one, which is c, your x plus 2 we divide, so you just have only x squared. Okay, so this was where we got that yesterday. Okay, no, it wasn't here. All right, so you cancel this, the equal denominators. So if you do that, you are now going to have that only 3 will be equivalent to ax into x plus 2, then b into x plus 2 also, then plus cx squared. Okay, so what did we do? It's unfortunate that some of us that were in that class yesterday are not here. Like Munachi is not here yet, and some others are not here. So I don't know how they are going to get this, although we'll have the recorded ones. So, but please, you can begin to tell them in the group to join the class. All right, so because it won't be good that we are done and then they will miss out. Okay, so what did we do yesterday? We used the substitution method. That is, we substitute x and then eliminate some. Okay, so we first of all substituted our x as minus 2, and if you put x as minus 2, it will eliminate this and this. So when we did that, so of course, if you put x as minus 2 on a constant, it will still be 3, and that will be equal to, if you put x as minus 2, the whole of this will turn to 0, the whole of this will also turn to 0, and then here is going to be c times minus 2 raised to power 2. And then of course this is going to give us 3 is equal to 4c. And so our c alone is equal to 3 all over 4. Okay, so this was what we got for c. So let's now go on. Okay, so the next thing is to get our a and b. And then if you allow me now, we can go ahead and open our brackets now. Alright, so even though, okay, we can get our b by making our x to be 0. So we said that if we make our x to be 0, this one will turn to 0. So if we make our x to be 0, this particular place will turn to 0. So everything here will be 0, and then the third one will also be 0. So we eliminate a and c. So, and then we'll be able to get our b. So let's quickly do that. So if we make our x 0, the 3 will still be the same, and that will be equal to, here will be 0, while here is going to be b times 0 plus 2, which will be 2b, and then this last one will be 0. So we will have 3 is equal to 2b, and so our b alone is equal to 2 over 3. Okay, so we have gotten the value for b and c. So it was to get our a, that was where we were yesterday. And I hope that some of those people who were here are here now. Lawrence, you're welcome. That's praise. Okay, so now let's begin. And to get our a, we said we will need to expand this. So let's try that. So we are going to have 3 is equivalent to, now this was where we made the mistake yesterday. We got this one correctly, ax squared. But the second one, I wrote 2a instead of 2ax. Of course, if ax multiplies 2, you will get 2ax. Okay? It should be 3 over 2. Yes. Oh, thank you, Patrick. All right. Oh, my God. You see all these mistakes. I don't know why I'm doing that. Okay, so this is 3 over 2. If you divide both sides by 2. Thank you. Okay, so back here, that was exactly the same thing that happened yesterday. And this is why, if you are writing maths exam, you must be very careful. And one of the things that makes you careful is that you practice a lot of the times. You know, for instance, if I was a student and I'm doing all of this and I'm making mistakes, I am coming back to it and I'm seeing my mistakes. One of the things that will happen is that if I get to exam, I'm going to be more careful in those places where I made mistakes. Yeah, David, I've made that correction. Thank you. Okay, so here now we are going to have, okay, I'm opening here. So this is supposed to be 2ax. So let's go over to b. So b is going to be bx. Then b times 2 is 2b. And then finally we'll have cx squared. Okay, so let's do a factorization now. So this one has square and this one has square. We gather the two of them to give us a plus c into x squared. Okay, if you open that bracket, you will still get back what you had before. So we have not changed anything. And then the one of x is now going to be your 2a plus b all in x. So the only constant here is actually 2b. And if you use that one, you see that you still get back this 3/2. Because remember what we said about equivalent polynomial? So the constant on the right hand side will be equal to the constant on the left hand side. So your 3 will be equal to 2b. So which will still give you this 3/2. So that means the method of substitution is also correct. Ebuka, you are welcome. Alright, so now, but that's not our interest. Our interest is to get a. Okay, so there are two places that a is contained. One is in the coefficient of x squared and the coefficient of x. Okay, so we can use any of them. And if I were you, I will use the coefficient of x squared, because the one of x contains 2 in front of a. So that will take my time. So I will just use a plus c is equal to the coefficient of x squared on the left hand side. And of course, the left hand side does not have x squared. That means the coefficient will be 0. Okay, so this is therefore going to give us a plus our c we already have here as 3/4 equal to 0. Therefore, our a is equal to minus 3/4. So if you remember yesterday, when we did something, there was a place we got this minus 3/4 for our a, but the other one gave us 0. So which was a proof that we made a small mistake here. Alright, so but I'm sure that it is clear now. So finally, we now have our ABC. So we can come here and substitute. Alright, so let's substitute. So our a is minus 3/4. Remember what I said? That when you're writing a fraction as a numerator, you can bring down the denominator down to join the denominator of the general fraction. So this 4 here will join the x that is here. So you just have 4x. Okay. Then, okay, Gozrim, you are here. Okay, thank you. Yeah, it should be 3/2. Meanwhile, now you're saying that late, so it means that your video is backward. You can drag the line to get to the end so that you will be following us properly. Okay, so yeah, Mira, you just entered 2. Okay, we have corrected that. So this is going to now be, our b is now 3/2. So we keep the 3 up and bring the 2 down. So the 2 will now join this x squared. Okay, and then finally our c is 3/4. So we keep the 3 up and bring the 4 down to join this x plus 2. Okay, and you are done. But you know, we like to, I was saying something in class today, that if this was exam, you will not see this in the option. Why? Because we don't like to keep negative to be in front. So instead of writing minus x plus y, it's actually better to write y minus x, because they are the same. So you can decide to bring any of the positive ones to the front. So if I bring this one to the front, I will have 3/4 into x plus 2. Then any of these can now follow. So I can have minus 3 all over 4x, then plus 3 all over 2x squared. And that is our solution. Okay, so Philip, you're welcome. Alright, so that is the solution for this particular example that we started yesterday. Okay, so now, like I said, I will give that second example for you to try it as an exercise, and then you can submit it on this channel at the end of the class. You have 2x plus 1 all over x squared. Okay, split it into its partial fractions. 2x plus 1 all over x squared. Okay, so when you have repeated quadratic roots, so what if we have repeated quadratic roots? What do we do? Okay, I think I wanted us to do another. Anyway, let's go on. So repeated quadratic roots, that's what we want to do. Okay, so the one we just finished now is distinct quadratic roots. Oh, sorry, I've been calling it roots, but of course you can call it roots or you can call it denominators. So repeated quadratic denominators. Okay, so when the denominators of the fraction you want to split are quadratic and they are repeated, how do you go about it? Okay, so I believe you have written this example, so let me take this up. All right, so let's go. So now all of these follow the same principle, and they follow the principle that we have already outlined. Please explain the last part. My network is poor. Okay, what is the last part? Is it the part where we saw A, or the part where I joined everything? Okay, I think that's where you mean. All right, look at what I'm saying there. That, okay, let me remove here. That if you permit me to remove here, okay, so that if you have I can see many of you are fluctuating, maybe because of network. Sorry about that. That if I have something like 1 over 2 all over 3, okay, so that this is the same thing as writing 1 all over the 2 should come down. The 2 that is a denominator in a numerator should lie the denominator that is down. So that's actually what I did here. So if I have something like let's say 3 over say 4 all over x, so we are saying that it is okay to just write only 3, the numerator, and then bring down this 4 to join the x below. Okay, so that's actually what I did there. Ibokwe David. All right, so since my a is minus 3 over 4, so I left only minus 3 up and brought down the 4. So the 4 will multiply x. So here my b is maybe I should remove here. My b is what is it, 3 over 2. So I should bring down the 2 to join x squared. And finally my c is 3 over 4. So I should bring down the 4 to join x plus 2. So that's what I did there. Okay, and I hope that is better now. Okay, so let's go back to where we were. So repeated roots are forgotten ed. Okay, so repeated quadratic denominators. How do you do that? So let's start with some examples. X squared plus 1 all squared. Okay, so see what we have here now. You can clearly see that the denominator is quadratic and there is a repetition. You know, you can write this as 4x squared plus 2x plus 1 all over x squared plus 1 times x squared plus 1. That's actually what we mean by repetition. Okay, so square means repeating something, multiplying it by itself 2 times. Okay, so now how do you do this? The same method, that's what applies. But the only thing now is that you are going to have 2 fractions and their denominators will be x squared plus 1. Now because it is repeated, So the next one will be x squared plus 1 all squared. Okay, now because you are talking about quadratic denominators, so all the numerators will be linear. So the numerator for this one will be ax plus b, while the numerator for this one will be cx plus d. Okay, let me check. Okay, yeah, he's actually saying that here. Okay, yeah, Munachi is here. You are welcome. Okay, it's my network. My network is a little bit shaky, but I think it's excellent now. Okay, so let's try to go back. Sorry about that. The network is shaky. Okay, sorry about that. I think it's still shaking. Oh, poor network. The stream's current bitrate is lower than the recommended bitrate. We recommend that you use a stream bitrate. Okay, why is it? Okay, just give me some time. Let me check the settings. Maybe it's from here. It's already streaming, so I cannot change it. Okay, permit me to end the stream and then start again so you can join again. Let me end this stream.